Good afternoon, everyone, and thank you for joining us for today's webinar. My name is Arif Rafiq. I'm the Industry Manager here for Transportation here with Esri Canada, and joining me for today's webinar is my associate, Brandon Whitley. Basically, today we're going to be talking about creating your own linear referencing system. So, of course, we've titled our presentation, Don't Be Afraid to Create Your Own LRS. I think when we get into it, it's really not all that challenging, and so we want to walk through today the creation of a linear referencing network, and we're going to have some fun today. So, as I said, my name is Arif Rafiq. I'm the Industry Manager for Transportation, and I'll let Brandon introduce himself.
Hello, everyone. As Arif said, my name is Brandon Wheatley. I'm a GIS analyst with the Community Maps program. And we've got a pretty action-packed hour here for you guys. So if you're ready to go, I'm going to pass things back over to Arif to kick things off.
Thanks, Brandon. Okay, so we got a little bit of housekeeping stuff to go over first. We are encouraging questions and answers, or encouraging questions. We'll try to provide the answers as best we can. And the way you're going to do that is in your WebEx panel, you have a My Q&A panel. Make sure you ask to all panelists. That way we will all see it. Sometimes if you ask a specific panelist, we happen to be a little busy, so sometimes we might miss it. So please do get your questions in. What we'll try to do is we'll try to collect these questions, and at the end of the presentation, we'll go through and answer them, okay? So look at the instructions on your screen to find the Q&A panel, and you'll be fine with that. So the agenda today is we're going to start off talking about, very briefly, how linear referencing is different from traditional road segments. We are doing this webinar basically from demand from Canadian municipalities out there. Most of you who are on the call may understand that most Canadian municipalities manage their road network in a segmented fashion. And so while many municipalities are actually looking to move beyond that to the world of linear referencing, many are also pretty unsure as to whether it's good, whether it's useful, and I'll be the first to tell you it may not be the best choice for everybody, but for some municipalities it may be the only way to go. So we're going to very quickly identify what makes them different, why linear referencing is different from traditional road segments for municipalities. We're going to take a publicly available segmented road network from open data. You're going to watch us do that. We're going to bring it into ArcMap, and we're going to take that publicly available road data and convert it to a linearly referenced road network. And we're going to do it in such a way that all of you who are listening will be able to do this yourselves. We wanted to make sure that we use basically publicly free data in order for this to happen. The only requirement, though, of course, is you're going to need ArcMap on your machine, and you're going to need the Roads and Highways extension. So I know that's a bit of a caveat. Not everyone else here is going to have it, but this is recorded. So when you do call your account manager and get that extension, you'll be able to walk through this demonstration and actually get it done. But we wanted to, again, make sure that it's available for most people. The other thing that we're going to cover as well is we're going to cover data structure for best practices for linear endpoint events. The two, we have three different events we're going to go through later on. Two of them include road class and rail crossings. We chose those because road class is the linear event and rail crossings is the point event. We figured they'll probably be nice. But we're going to do our best to get through this material. It's quite a lot, so we will probably go a little bit fast. This is a whole lot of text on linear referencing. I encourage you to look up other material, third-party material as to what it is, but essentially it is a way to manage data, or what we call events on roadways, in other words, linear assets, by using things like measures across offsets. So we define where the zero location would be of any particular road, and we assign locations for things like guardrails, accidents, road classifications, rail crossings, by using a defined measure away from that zero or other features or landmarks along the road network. It's a very different way from managing a road network using a segmented approach, in which the entire road network is divided up in segments, and each segment is given an ID, and then assets are attached to the ID. Very different way to model the road. Neither one is right or wrong. They're simply different. So let's jump right into the data, and we'll hope to give you a more visual indicator of how this is actually going to work. By the way, anybody know what city that is? Maybe. I don't know. I'll let you guys answer. You can dump it in the QA if you know what city that is, and we'll think of a prize for the first person who names that city. All right. So Brandon, actually no. Before Brandon takes it over, I wanted to go over where we're going to get some of this data. Oh, look at that! Look at that! We're getting responses. I love it. Yes, correct. It is Calgary. It took me a while to figure it out too. We're based in Toronto, so we don't know Calgary all that well. Anyways, let me go through some of the open data that we're actually going to be using to collect this. So just bear with me while I share my screen, and you should be able to see the website. So you are looking at the Esri Canada website. If any of you go to a browser, if you got one in front of you, all you got to do is type in data.tol.ca. We chose to use the Township of Langley data. So this URL takes us to the open data site for the Township of Langley. And from here, we can either do a search for data, and I think there's actually another way to do this. Yeah, if we go to transportation, I think it gets exactly what we want. So I'm going to click on transportation, and voila, we have some data that we can work with. The first piece of data that we downloaded was the roads data set. So if you click on that, and then look, you can examine it here, take a look at all the different attributes of that road data set. This is a traditional segmented road data. Now, I must, if anybody from the town of Langley is on this call, there was no particular reason we chose your city. It just, it was there. I literally put my finger on a map and said, let's just choose this. So no reason we chose Langley. Okay, I want to make sure that's clear. If you click on the download button, actually, no, there kind of is a reason. You have a great open data site. How's that? That's a good reason as to why we chose Langley. So if you click on the download button, what we did is we downloaded the file geodatabase version of this roads data set, and you're going to see in Brandon's screen shortly what that looks like once we do bring it in. The other thing that we downloaded as well, if I just click on back, we took a look at rail crossings. So the rail crossings data is a point data set, and it's a separate data set from the roads. So we wanted to bring that in as well. It also gives us another way to bring to create data in our linear network, and having two different data sets to do that, it makes us look at two different methods to bring the data in, which I think is useful for our listeners. So same deal. Go to download, find the file geodatabase, click it, and bring that into your environment. Once it's in your environment, you can fire up ArcMap, and I will let Brandon take it from here and show you what to do.
Awesome. Thanks, Arif. So just give me a second here. I'll share my screen with you guys. Okay, so as Arif said, we downloaded this road data from an open data website. I have brought the roads into ArcMap. And now, before we can set up our linear referencing system, we need to analyze our data in both attributes and geometry, as there can be some potential issues lurking in the data that can cause some problems later on when we create our LRS. So let's just zoom in here. I'll just pick a kind of a random road segment. Let's zoom in and check out some of the attributes that we're working with. All right, so I've selected 4 road segments here. So looking at the attribute table, I'd like you guys to note how common a lot of these attributes are. We can see our street name ID fields are all the same. They all share the same road name. They all share the same year added and road classification and so on. And this is a really key indicator. This tells us that this road network segmentation is defined by the intersections of the roads and not so much the data in the attribute table. So this is a really key point to understanding linear referencing systems. And now, before I go any further with the demo, I'm just going to take a quick second to jump out and just let you guys know, if you are new to linear referencing systems, that we have a whole bunch of resources available on resources.esri.ca website. And if you come up to the top here and go by industry, come down to transportation and select roads and highways, there is a ton of data and a lot of, as you can see, previously recorded webinars to do with LRS systems. And the one in particular I'd like to highlight for you guys is this one here, Manage Road and Highway Infrastructure Using LRS and ArcGIS. So this will be a great kind of intro to kind of further explain some of the details and help you better understand the benefits of an LRS and why one would choose a linear referencing system to model your road data. Okay, so now that we've got that out of the way, I've let you guys know where that is. Again, resources.esri.ca, roads and highways. I'm going to jump back into ArcMap and we'll get this demo going. Alrighty. So the first thing that I'm going to do here today is I'm just going to create a Scratch database just to house the data that we're going to be working with, because we're running a couple of tools and stuff. So to keep everything nice and neat together, I'm going to make a new database, and we're going to call this one here Langley Scratch. So now I'm going to run a copy features tool to simply just copy the features. Oh, this guy here. Copy features, there it is. And simply just to load that the data that we downloaded from the Open Dataset website into our Scratch database. And in doing so, I'm going to come down to my environments here, and I'm going to disable Z values. When setting up an LRS system, you can absolutely use Z values if they're available in your data, but for the purpose of today's demo, we're just going to keep things simple and disable those Z values. And as of course, conveniently, we're going to call this roads no Z value. So I'm going to go ahead and run this guy here. Perfect. So now I'm going to remove the original roads that we were working with. We're going to stick with the roads no Z value for the majority of the rest of this demo. All right, so the next tool that I'm going to run here is a densify. And what densify does, that's dissolve. Densify is going to add a series of vertices along our road network while at the same time replacing any curved segments. So if your road network has any Bezier curves or any arcs or anything like that in your data, we want to remove those before creating our LRS. And we're going to use a densification method of angle, and we're going to set that to 2 degrees. Essentially just saying that from our original data, we don't want our offset to be any more than 2 degrees away from the original arc. So try and preserve the data quality as much as possible. So now that we've got that set up, I'm going to pass things over to RF, and he's going to take you guys through the next step.
Thanks, Brendan. Let me share my screen here. All right. So we are back now, and we've got this roads no Z value feature class in our map. So I'm just going to open up the attribute table to let you take a look as to what's going on inside this attribute table. We've got quite a few attributes. Remember, this came from the open data sites. There's lots of stuff here that we can work with. If I take a look at the full data set, it's got about 3,500 rows in here and quite a number of attributes. We have street ID, street name ID. We have an alternate street name, road name, a few things defining the actual street. We then have this funny one called year added. I presume that that's when the year, that's when that particular segment was added to our network or built originally, because some of these are pretty old. 1938, 1944. Wow, man, Langley's got some old roads out there. Hopefully they've been maintained since then. We also have another one called road classification, owner, and we have classification text. We also have, as we go down, we can more deeper in the detail of classification, cross-section type, and a little bit of as-built info. So what we want to do first is we want to create our base road network. And our base road network is designed to be very, very simple. All we want, really, is a list of roads that are uniquely identified and can encompass the entire city or the entire area of interest. We don't have to concern ourselves with segmentation at this point. We want our data to provide the segmentation. We don't want our streets to be segmented. So essentially what we're going to do is I'm going to take a look at this data table and split out our network from our events. And if you look at the first few columns, we have street ID, street name, and then we move on to this year added bit. So if I just look at the street ID, street name ID, and road name, this might give us what we're looking for as a base road network. We can choose whatever we want. We don't have to choose road name. We don't have to choose street ID. In fact, some of the best practices state that you might want to actually use a globally unique identifier as your road identifier. And we don't have that in front of us. And remember, we want to try to make this as simple as possible. So we're going to use some existing data. We've decided that we're going to build our base network off of road name. So this is going to be the base network identifier for this road network. Once we've done that, after we've built our road network, we're going to add a few events. The first event that we're going to add is we'll use this column here, this attribute called year added. The year added would certainly be duplicated. I mean, just take a look at these ones right here. Just like Brandon described, we have a number of road segments that may or may not be contiguous and have similar attributes. In this case, if you look at 24th Avenue for this stretch, we have 7 records here that all say 1946. So in our event table, we want to merge those down so it becomes a single record saying where the 1946 section began and ended. So we're going to isolate year added as an event. So we're going to do that later. The other event that we can do here is road classification. I mean, take a look at this. Road classification arterial major is mostly, at least at the top of this list, we have a lot of arterial major. As we move down, we get through the rest of them, and I'm sure we can go through the list and find out all the different road classifications, but I'm going to guess we probably have about a dozen or so across 3,500 road sections. So we're going to identify road classification as another event. I'm going to ignore the detailed bits here. So as we get to this subclass, I think as a production environment, we may want to consider this, even make this a third event, or we can bring it into the road classification. The choices are endless, but for our demo, we only have a limited amount of time. Those are the two that we're going to use. Those are the first two we're going to use. The other one that we're going to use is, like I said, is coming from a secondary data set. And if I open up the data sets that we downloaded, we do have that rail crossing data set. So here it is. I'll bring it onto my screen. You can see the dots appear. This is going to be our third event, and it's a point data class. It's got a whole bunch of columns for a whole bunch of data to describe those rail crossings, and we're going to use all of them as one rail crossing event. So we have a variety of things to show you, and it's going to be very, very interesting as we go forward. Brandon, take it away.
Awesome. All right. Thanks, Arf. Let me just share my screen with you guys here. Okay, so Arf was saying, he's explaining that we need to establish a route ID for our LRS. And if we do a quick sort here, he was looking at street name ID or road name. So let's have a quick sort here on our street ID name. And we notice that we have 3 values in here that are null. Now, if we had selected street name ID as our route ID for the LRS, this would pose a problem. We cannot have null values here as the route ID. So we would either need to populate these fields with some sort of value or actually potentially remove them completely. The choice is up to you, but either way, they need a value. But for this demo, like he said, we've decided to choose road name. And just doing a quick little sort here, we can see we have no null values. So that's good to go. There's going to be no problems here with any null values. So let's move right forward into the next step here. And the next tool that we are going to run is going to be a dissolve. And we're going to dissolve our roads here by road name. And what this is going to do is this is going to join any road segments with the same name, which is great. That's exactly what we're looking for. So we also notice down here at the bottom we have a couple of options. For the first time here, I'm going to unselect create multi-part features because we don't really want any of those right now. And I'm going to select unsplit lines. And what unsplit lines does is it's only going to dissolve lines when the 2 end vertexes of two segments share the same end vertex. So they've got to be overlapping. So if they're not connected or if the vertices aren't actually snapped together, then our road segments are not going to join here. So we're going to come up here, and we are going to call this roads dissolved by road name 1. And without getting too ahead of myself or giving anything away, let that 1 be an indication that we may have to run this tool more than once. Alrighty, so that finished here. Let's take a look at some of our results. Let's open up this attribute table. And we notice now that we have sorted everything here by the road name, and we have lost all the other attributes. That's because we just want a simple, basic road network. And if we come back to the street that I looked at earlier here, and we notice it was broken up into multiple different segments, we select it, and we notice now that it has all been merged into just one road segment because they were all connected and all shared the same name. All right, now for the next section, if Arf's ready for us here, I'm going to pass things back over. Take it away.
Thanks, Brendan. I hope our listeners aren't getting dizzy with the back and forth here, but hopefully you find it entertaining. So here we are with our same road network. We also have, I've done the dissolve on my version as well, and we can see that we've got our dissolved road names. If I open up the attribute table, it's just like Brandon had. We have a list of roads that have been dissolved by the road name. The first thing that you might notice is, well, hold on, what's going on here? We have 2 road names that are Highway 1. So what's happening here? Let's investigate this a little bit. And if I click on this, you'll see that, okay, if I zoom into what it is, you'll notice that Highway 1 is the major highway that's going through the town, and the two records represent the two different directions of travel. Okay, that makes sense. That's kind of what we're after. But you got to remember that if we were to dissolve our original data by road name without allowing the multi-part or unsplits, these would actually be merged into one, because the road name for both of them is the same. They would have been merged into a single multi-part feature. So as we kind of walk through this, we got to remember that we're going to do this again, kind of how Brandon hinted that, you know, he named the first one dissolved by road name 1. We're going to have a road name 2. We're going to have to do this again after we fix the errors. So this may not seem like an error at first, but notice if we do dissolve it, it will merge, and that would be bad. We got to make sure that these are two separate entities in our linearly referenced network. And since they're the same name, and we've decided to use road name as our unique identifier, the only option here is to make them unique. So let's go ahead and do that. But here's the key. I'm not going to do it in my dissolve by roads name. I'm going to make sure I do it in my roads z-value over here. This is the source data where I want to actually make that change. So let's go back. I'm going to open up the road name, and we got a whole bunch of records here. So let me just select the records that I'm going to separate them out. So we got to make sure we select all the eastbound records and all the westbound records. And I'm doing this by memory, so I'm hoping I got that right. Yeah, it looks like I got it right. If you're looking at the screen, you see this is the northerly, this is the northerly direction of Highway 1. What that means is this is the direction that's going westbound as it travels. So those are the 4 that I've selected. So I'm going to go ahead with those 4 and just do a quick field calculator here and make sure I change that to number 1 highway westbound. Yeah, right direction, westbound, that's right. Okay, so we're going to go okay. And we get the westbound, and I'm going to select the other ones. Make sure we do the same, field calculator, and change that to eastbound. Now, once I've done that, and if we were to dissolve this again, the westbounds would be their own single road entity, and the eastbounds would also be their own single road entity. That is what we're trying to achieve here, is make sure we isolate each and every single road entity, I guess you want to call it, by its own unique name. And this was a good example of what to do. There are more. I'll let Brandon show you the next one. Go ahead, Brandon. It's all yours.
Okay, great. Thanks, Arif. Just going to share my screen with you guys again. So as he said here, we really need to dive into this data and continue the analysis to try to minimize the amount of errors that we might run into later. So I'm going to select another road segment here. I'm going to choose number 10 highway. Let's go and select this. We've got 13 road segments here. And one thing that can be a problem, let's give my ArcMap a moment. There we go. One thing that can be a problem here is if when we zoom in close and analyze the actual geometry here, forgive my base map for loading a little bit slow here today. Actually, you know what? For this, I'm just going to turn that off. Okay, perfect. There we go.
My base map's better than yours.
Yeah, I'm sure it is. Yeah. Alrighty, so we keep zooming in here. So let's analyze the actual geometry. One thing that may actually be a problem is if we have a disconnected segment. So as you mentioned earlier, when we had that unsplit lines checked, if these were actually touching, they would have joined together. But because they're separated, if we were to have joined these, they would have become a multi-part feature, and it would have been really messy, and those roads would have been disconnected. So this is the type of edit that we'll need to make. It's just a quick little change here, and let's connect these road segments. So let's start a little edit session. Zoom in here nice and close. And we'll connect these two. I'll save my edit. And now that road segment is connected, and that'll be good to go. When we try to run our dissolve again later, that will all now merge, and we won't end up with duplicates, which will be a problem in our route ID field. Another example of a problem that we need to find. I have a feeling RF has a few more. Let's see what else he's got.
Thanks, Brendan. And thanks for giving away the secret. Yes, we do have a few more. So here's our dissolved table again. This is the one that we tried to dissolve at first, and we can see that we have our failed Highway 1. There's more here too. Take a look at these lanes. I got a lot of road names that actually say lane on them. So what the heck is going on here? Let me see if I can select all of them. So I'm just going to do a quick ascending, and let's see if I can find, oh, there we go. I'm going to find the bottom of that lane and click it, and I'm just going to zoom to selected, see what we got. Wow, these lanes are all over the township, right? They are everywhere. They are valid lanes, I would presume at this stage, and we probably want to keep them in our actual road network. But the only way to do that, if we choose to use road name as a unique identifier, is, well, we got to kind of make them unique. So really, in order to make this work, we would have to make the lanes unique. There's more too. There's this thing called preliminary. If I click on those, we're going to find a couple more segments, and oh, we also have these funny ramps. We know what those ramps are, right? Those are the ramps to Highway 1, and if I click them, you saw them highlight on the screen. So let me, if I can isolate those, you'll see all these ramps show up in yellow as I highlight them. So there they are on the screen. These are the ramps. Yes, we do want them in our final road network, but really the only way to do that is to go through each and every one and rename them so that they uniquely identify, you know, which road that ramp comes off. So you would say, you know, Highway 1 westbound to Edward Street northbound, or something like that. We'd find out some way to uniquely identify them, and then we can proceed. In the interest of time, we're not about to go ahead and rename 159 records, so we're going to do something that you probably should never do in your real data set. We're going to delete them just to make this a whole lot easier. So I'm just going to clear that selection, go back to our source data, go to the road name, and just do a quick select by attributes. And we want, actually, no, I guess I can do that, but the other way I can do it too is just sort ascending on road name. There's our lanes. I'll find the first one, go right down to the end, wherever the last one was. I should probably done this select by attribute, shouldn't I? Oh, no, there we go. So there's the end of the ramps. That should be everything. And turn on my editor. We're editing this one. And delete it. Don't do this at home, kids. Or don't do this when you actually want a network that's navigable, because now we've isolated the highway. There is no way to get off the highway into the city. But hey, this is a demo, and we want to make sure we get through this quickly. So I've gone ahead and deleted them. So I'm going to save my edits, and if I look at the roads nosy, you can indeed see that we have cut out all of those ramps on our highway. There's the ones. Oh, my base map is not better than yours. Look at that. It's slow here too.
Ah, see, I heard you.
I jinxed myself. I jinxed myself. That's what I did, didn't I? Oh, my goodness. Okay, terrible. Oh, there it is. All right, fair enough. So we've cut out our ramps. We've cut out our lanes. We've cut out those funny preliminaries. Essentially, we're trying to reduce this down so that we have unique road names. I think there's a few more. Is there not, Brandon?
I have a feeling. There might be one more. Right. At the very least, let's take a look.
Let's take a look. All right.
Perfect. So let me come back in here and share my screen with you guys. And I'm not going to lie, I pre-cooked this one a little bit. I ran my select by attribute already and zoomed into my preferred area so that the base map was ready to go for you guys. So for this one, I have decided to choose 0 Avenue and just take a quick look here. We've got 18 features, and it appears, and I'm going to be honest with you, this is a continuous segment. There are no gaps in the line segments here. I've done a little bit of work. I'm not going to scroll around and mess up with my base map here, but there are no gaps in this road segment. It is continuous, and when we run our dissolve again later, this will merge into one feature, and that will work just fine. All right, let's continue this here, and let's take a stab at another road. Let's try 1 Avenue, or first, however they want to consider that. Okay, so this is a little bit of a smaller one. So I'm going to dare to zoom in again. And okay, there we go. So I move this guy. Actually, I'll just close this. Perfect. So what we can see here is we actually have that gap that I was referring to earlier, but this type of gap is different. This is a valid intentional gap where you can see the road network starts in one area, comes to an end, and then continues on later on. And this is okay. We actually are allowed gaps in our road network if they are intentional, and the road network is set up that way. We just need to make sure that we identify this is actually intentional. So this will be okay, and you'll see that later. And let's take a look at one more while I've still got my screen going before I pass things back. Let's try 10 Avenue as well. I'm going to zoom in. Oh, come on, base map. All right, I'm bailing on the base map for this one. Okay, moving ahead. So what we can see here is that for 10 Avenue, just like First Avenue that I was looking at previously, we have multiple gaps between our road segments. And again, this appears to be a valid intentional gap. The road starts in one area, stops, continues to another, stops again, and continues. This is okay. This won't actually pose a problem later on down the road because this is how the road network actually looks. So again, just showing different types of errors or different types of things that may look like errors, but these are actually okay. Now, if we might have a few more, I'm going to give this back to RF, see what else he's got, but I have a feeling we might be getting down there.
I think you're right. I think you're right. We are getting close, but we still got a few more we want to go through. So you might be, everyone might be getting sick of these errors, but hey, there's a reason we're going through them, right? There's a reason we're going through this is because we found these errors, and chances are you might find them in your network too. So we want to identify them so you know what to look for. Here's another one that we stumbled across, and I have to admit, this one I kind of found by accident. I actually don't know how I found this, but I was looking through the data and I discovered this funny one called 264 Diver. When I was looking at the data, I saw, okay, well, there's 264 Diver. You see it highlighted in yellow. This is on the southern side of the township. And if I click on the next one, you can see the same road name, 264 Diver, and it just kind of continued south a little bit. And then we have another road here, also called 264 Diver, but it's a branch. This is what's known as a branch route. So it's all 264 Diver coming in, and then we branch it, and the failure here is that they're named the same. Well, hold on. Not really. If you look at this alt road name, so I'm looking at the source data now, the alt road name actually does differentiate between Diver South and Diver North. So had we chosen to use alternate road name as our unique identifier, this would have been okay, kind of. The reason we didn't is because if you look at the rest of the data, almost all of the alt road names are null, which would definitely have made it a bad choice. So even though we do have a separation in terms of alt road name here, in our chosen field, they are not unique. And this would fail when we're creating that network. It does not allow, actually no, let me rephrase that. It will allow branch networks, but you'll discover that the calibration is going to be completely wonky. And we want to save you the trouble of having failed calibrated networks. So remove your branches, or at the very best, no, sorry, rename your branches. So the correct way to do this would have been to maybe even take that alt road name and call this 264 Diver North, call this 264 Diver South. In the interest of time, I'm going to do exactly what we should never do and wipe it out. We're getting rid of that road network. Okay, so now we have two road sections, both called 264 Diver. It is no longer a branch. This will work just fine when we go ahead and create our network. So I'm going to save my edits. Once that thing goes away, there we go, save my edits, stop saving, perfect. Do we have any more, Brandon?
I think we might. And
okay.
This one, I think I've got one that might actually be a little bit different. We haven't seen one of these yet. So let me show you guys this here. I'm just going to share my screen. Perfect. Okay. So now we're looking in, I guess this is the northwesterly region, and we're looking at the Golden Ears Bridge. And what we notice here is when we select this bridge, if I zoom in here a little bit more, oh, you know what, I'm bailing on the base map. It's taking too long. Okay, perfect. So what we can see here is that when I select one of the line segments, I actually get both of them. So these are two completely different line segments. They're not actually connected, but it looks like what we're dealing with here is a multi-part feature. So what we would need to do before we create our LRS system is to explode this multi-part feature. We do not want this before we create our LRS system. So I'm going to come into my advanced editing toolbar. I'm going to have that selected, and I'm going to explode this multi-part feature. So now when I select one segment, I actually only get one, and I select the other, and I get the other. That's great. But now we have the same problem where our road name or our route IDs are no longer unique. So I now need to rename these as well to give a justification to show that they are, in fact, two different segments. Or when we do the dissolve again, they'll just merge right back together. Okay, so this one here looks like it is traveling northbound. And we'll come over on this side and change this one. Oh, look what I did there. Let's bring that back. And this one is southbound. And just like that, now we've exploded a multi-part feature, given them unique road names so that when we create the LRS system, these will be 2 unique roads. All right. Now, if we have any more, I think I'm done, but I'm going to pass things off to RF to see if he's got anything left.
We got another one. We got another one. Anybody sick of this yet? We got more. We got more. I think this is the last, though. You know what? They're quite honestly, there may be more, but I think this is the last of the big ones that we're going to cover as well. So here's the same place we're talking about. This was the Golden Ears Bridge, and we have these 2 on-ramps that proceed onto the Golden Ears Bridge. And if I just select them, you'll see that, again, they are named the same. It's the same name for those on-ramps. So I'm just going to quickly fix this by starting my editing. I don't want to clear these ramps, actually, so I'm going to keep them in here. Let's make sure I'm editing the right thing. Over here, we're going to call this Golden Ears Bridge on-ramp. Well, I don't know. I think this was 201. No, that was 199, wasn't it? That was 199A, and we'll take this and we'll call it on-ramp 201, just simply referencing the street that serves that on-ramp. So I'm going to stop editing. Great. So now those 2 records, if I can select them. Okay, what have I done wrong here? Give me a moment. There we go. Wrong tool, RF. Okay, so if I select them, now I see that I have my 2 uniquely identified names. I also have a little bit other funny stuff going on here. We have these little streets that also are 199A, but you can see, let me zoom in a little bit here. This is actually a very common thing that's happened in a lot of larger road networks, is you have a single road, in this case 199A, which comes up and it splits because it becomes divided. And they're both valid. They are both 199A. But in a real-life example, what you want to do is do the similar thing that we've done with Highway 1 and name one of them northbound, the other southbound. There's also this other funny thing here, which I discovered, and I don't like either. They're all named 199A. So in reality, you will want to rename this. For our demo, we're going to do the fun thing and get rid of them. I'm sure you guys are loving this as we do. And we found some more over here too. I think there wasn't that much, but let me just quickly select them. Yeah, so that was it. There was these ones, 201 Street, and I wanted to get rid of just these, because if I do that, we then have a valid 201 Street, which is not branching or connected anywhere else. So the 201 just goes straight through. All right, perfect. So I think that gets all the edits that we wanted to talk about. There certainly may be more errors in here, but for the sake of this demo, we've covered what we believe are some of the more common ones. So definitely not exhaustive, and I can almost guarantee you there are more errors. In fact, there actually are more errors we're going to stumble on accidentally somehow later. But there are more errors. You're going to see how we found those again. But before I get to that, this is something that I saw when I was working with the data, and it's it's a traffic circle. And I get this a lot as to how do we model a traffic circle in the linear referencing world. So just to kind of go over this, I know it's a little bit of an aside, but we do have a lot of traffic circles, so I do want to cover it. The way it's modeled in this data set, you see how 201 comes up and then it goes up towards the right counterclockwise along that traffic circle and ends there. It ends there because there we have 100 Avenue that comes in and then continues along the counterclockwise direction along the traffic circle and ends where 201 again continues. So you see the way that this traffic circle is defined, perfectly valid way to do it. The traffic circle itself is actually going to have 4 names. Right? It's going to have 2 inbound, 2 outbound, and that's only for 2 crossing streets. Some traffic circles have many more streets. So if you use this model, you'll actually get quite a number of names for traffic circles. But I wanted you to be aware that this is a perfectly valid way to model one. Other ways include, having this as 201 and then stopping at the traffic circle and then re-continuing 201 on the other side without encroaching inside the circle. And then you have the circle as its own circular route. That's another valid way to do traffic circles. There are lots of ways to do traffic circles. I think there are like journal publications on the ways we can do them. And we've seen many, many different variations. So fear not, ask the questions, and we'll figure out the best way for your environment to model their traffic circles. But I guess that pretty much takes care of most of the errors that we have. We do have another, as I've hinted to earlier. But what we want to do is we want to continue on and assume that we've caught just about all the errors. And we'll let Brandon take over from here.
Yeah, that's right, Arif. I mean, last thing you guys want to see is an entire demo on just doing edits. So let's move forward here, and let's say that we've got all this ready to go. I'm going to share my screen with you guys. And now we're going to come back, just like we ran the dissolve in the beginning. Now that our data is all cleaned up and we've isolated all those potential errors, we're going to run the dissolve again on our road's no Z value. We're going to dissolve based on road name, but this time we are going to leave our create multi-part features enabled while disabling the unsplit lines. So this is going to join those segments with some of those intentional road gaps that we looked at earlier. So you can come up here, and we're going to call this guy road dissolved by road name 2, or final, because we're not running this again. Okay, so now that looks good. Let's give this a run here. Perfect. And if I jump into the attributes here, we can see just like before, we have our route ID, which is road name. And again, all unique values here. We don't have duplicates of Highway 1 anymore, or duplicates for Highway 10 or 0 Avenue or any of those. They're now all been kind of dissolved and joined together. So for the moment you guys have all been waiting for, we're finally ready to create our LRS system. So in order to start that off, the first thing I'm going to do is to create another file geodatabase. And I'm going to call this Langley ALRS. And if you right-click here and come into New, we are going to create a new Advanced Linear Referencing System. And this is going to bring up a great little wizard here. So we're going to jump right in, and we're also going to call this Langley ALRS. And the great part about this is that in a whole, it can be a complicated process, but through the wizard, it really does break things down into individual steps, and you can take it just one step at a time. So we're going to leave these first 4 fields as the default. Those are just the names of the individual tables and feature classes. That's fine. But one thing we are going to do here is we're going to come down to this XY tolerance, and we are going to load in the XY tolerance from that dissolved road segment that we just created. So in my Scratch database here, I've got my dissolved by road name 2, and we're going to select that. And if you noticed, before I did that, the spatial reference field down here was blank. There was nothing here. But when I applied the XY tolerance, it imported the projection of the spatial reference from that dissolved road network. So that's great. And we'll move forward here. Step number 3. Okay. So for this one here, this is just the schema of each of the feature classes in that table. We're going to leave these all default. That's good to go. All right, so now this is a field mapping step here. It's just good to note that the field name matches up with what it's going to be mapped to. If all of these are the same, we're good to go. We can move right on through this. Step number 5, this deals with if we're going to be using this ALRS in a multi-user geodatabase. Some of you may be going down that route, so this step will matter to you. But for the sake of this demo today, it does not, and we're just going to move right on. Step number 6 here deals with the Z values, which if you remember, we disabled right back in the very beginning. So we're going to move on from this as well. We don't need to do anything there. And just like that, we're done. Not quite. But we have created our advanced linear referencing system. And if I click Finish here, the wizard actually continues. So now it's prompting us if we want to create a new network. And yes, of course we do. So let's carry on. All righty. So now we need to give our network a name here. Our feature class name is going to be road name. And we're going to change our units of measure from miles into meters. All right, so I'm going to pause on this one screen here for a quick moment, because this is going to be key coming up later on. So we notice we have our route ID field, which we've talked about many times. You know what that is. It's our road name. But we haven't really mentioned or seen what this from date or to date is yet. And I'm not going to get into it too specifically because it can be kind of complicated, but essentially, in a fully temporal network, everything exists in both time and space. So, like I said, it's a little complicated. We could pretty much do a whole another webinar on it, but we need to remember these values. All right, keep moving forward here with the wizard. So we can establish some route dominance here. So when you're joining things or roads come together, which one is more important than the other? For today, it doesn't really matter. But we do want to establish some calibration. So what this is essentially saying is for those roads that had intentional gaps in them, how does it handle those gaps? So we're going to actually use an adding increment. and we're going to use an adding increment of 0.1. And what that means is if our first road segment is 50 meters long, it's going to go from 0 to 50. And then when it jumps to the beginning of the second part of the segment, it's going to start at 50.1. And if that is a 100-meter road segment, then the end of that segment will be 150.1. And the other option here is a cartographic realignment. We are going to select this so that if you do any edits to your roads, making them longer or shorter, that the measurements will update automatically to the edits that you are making. So we're going to move along here. And just like that, we have just created our LRS network. This is great. And again, if we hit finish, the wizard just keeps going. But I'm going to actually pump the brakes here and stop just for a moment before we load our routes. I'm going to come back to that to date and from date fields that we were talking about earlier. So I'm going to hit no here. All right, so coming back into our roads dissolved by road name 2 feature class, we need to add these from date and to date fields. They need to be present in our data before we can load the routes. So I'm simply going to add them. We'll do from date first. And of course, these will be date types. And I'll also add to date. And it's important to note as well that establishing a from date is fairly crucial. The data kind of needs to know, when is this all starting? Like, at what point is our kickoff? So I'm just going to come in here and do a simple field calculate. And let's, for the sake of simplicity, we'll choose January 1st. So now everything that our roads are set up to here is starting from January 1st, 2018. All right, so now that we have included those fields, we can come back to our network here, and I'll actually bring it in. And if we right-click on our LRS network, we can see we still have that option to load routes. So we don't have to go through the whole wizard or anything. Again, it's right here, and we can jump into loading our routes. So our polyline feature class is going to be our roads dissolved by road name 2, which we just added them. And you notice right away the from date and to date fields are automatically populated with the ones we just created. And of course, once again, we're going to be using road name as our route ID field, and we're good to go. Let's load the routes. Do I wish to launch the update calibration points tool? Absolutely I do. Whoa, okay. So what looks to be perhaps our most complicated wizard menu yet is actually one of the more simple ones, because it's the beauty of the wizard. What if you notice, it actually has populated a lot of these fields for us already. It knows our route identifier field. It has come up with a name for our calibration points. It knows our LRS system. It knows our road network. We don't actually have to change anything here. I can simply run this as it is, and our calibration points will generate automatically. So when you see that come up when you guys are creating yourself, don't panic. It might be the easiest one yet. All right, so if we go ahead and close this, you saw we created our database. We created the LRS network. Then we created our road network. We loaded our routes. We have our calibration points. And I'm done for a while. So I'm going to pass things back over to RF, and he's going to take you through explaining what just happened.
Just leave it to me to explain everything, right? Oh my goodness. No, that was fantastic, Brendan. It really was. We've created our road network. Oh, you wanted to say something? No.
I was going to say, well, you explained it. I did all the work, so your turn.
Fair enough, fair enough. No, he did. He did a fantastic job. That was it. We've created the base, a base road network, and it's already been calibrated, actually. So what I'm looking at right now is I'm looking at that calibrated road network, and let me show you one of the differences that's happened here. So what I've done is I've basically pulled up the road name feature class, and the way we've done that is if you open up the LRS, you'll see it right here. So I took this road name right here, dragged it to my map, and we've added some symbology to it. So, and I've also added the labels just to make things a little bit clearer for us to see. And along the bottom, we have Zero Avenue. Now, you remember Brandon went through Zero Avenue on the first part of this webinar, and it was a collection of different segments. If you look at it now, as you might expect, it's a single road segment with the from date of January 1st, 2018 that he's put in, the to date of null, which means that it will persist for the time being indefinitely, and we have a single route ID. But here's something also interesting. There's this tool button here that comes with the Roads and Highways extension, the new linear referencing extension, which allows us to figure out route locations simply by clicking on it. So let's take a look at this. If I take this little pointer now and click on any location of the line, I can now identify the exact measure that I'm clicking on. So it tells me that I clicked on measure 2071, that's meter 2071, and the maximum is 16,000 meters. So as I click along this line, that measure is updating to represent what point I'm clicking on. This is a result of actually having a calibrated representation of that roadway. So that's the calibration process that Brandon went through. The other way I can show it to you is if I bring in the calibration points and quickly do an identify on one of them at the end of 0, you'll see that this one, its measure is 0, meaning it's been calibrated to 0. On the other end of the street, if I click on this, the measure has automatically been calibrated to 16,408. Those are the defaults that Brandon was talking about. Now take a look at another roadway. Just for fun, let's look at roadway number 8 Avenue. Look at it. It's a whole bunch of disconnected sections. This is a multi-part feature, but it's been calibrated correctly. So if I look at the calibration points for this, and we just do a quick identify, you'll see the one on the western edge. Oh, there's probably more to it. Yeah, there is. If you look on the western edge, we start off, oh, there's even more to it. Okay, so we can see the different measures that are incorporated to the calibration points along 8 Avenue. With 0 Avenue, we only had 2 calibration points, but 8 Avenue has a whole bunch more wherever each and every segment ends and begins. I can use that same LRS location tool to identify points in between those calibrated calibration points. And of course, I can always adjust calibration. This is simply default calibration that came with it. It's based on 2-dimensional geometry. We did not use Z elevations, as Brandon pointed out. But, you know, the engineers in the room might want to actually know, no, I want to make sure that this calibration is exactly what I want. There's a tool here that allows us to do that. And, oh, it's not enabled right now. But with that, this is grayed out. But this calibration edit tool allows me to click on individual calibration points and actually change the values as we go. All right, so this is now the beginnings of that network. There was one other test we wanted to do, and I think for the sake of time, I'm not going to proceed through the entire test. But one of the things I wanted to point out was this idea of a non-monotonic route. It is a mouthful, I know, but there is a tool called Detect Non-Monotonic Routes. It's in the location referencing toolbox, and essentially what this is doing, it's going through all of our routes and making sure that the direction, or sorry, the measure is either increasing or decreasing. What we don't want, and what will really screw up our calibration, is if we have measures that increase part of the way and then start decreasing on the other leg of that road, and then increasing again and then decreasing. That is not at all what we want. We want a route that's going to be consistently increasing or decreasing, and the non-monotonic route does this. So I'm not going to go ahead and do it because we only have a little bit of time left in the webinar, but if you were to go ahead and do this, you'd actually get a list that you can browse through and it will identify every single route in your network, what caused the direction to increase and decrease. And you'll find, if you are brave enough to proceed with this with the open data set, you're going to find a whole new list of branch routes, what we call lollipop routes, and loop routes. They're these beautiful things that mess up calibration all the time. The good news is, though, we do have documentation that helps us identify that. So we'll include this link in later, but this is basically from the Esri website. We do have a method to calibrate these funny things called loop and lollipop routes. And if you look at these, you'll see that this is actually quite difficult to calibrate automatically. By default, it'll only give you 1 calibration point. If you follow the instructions here, it'll tell you have to add 2 calibration points to make something like this calibrate properly. Going further, we find these things called, this is also a loop. Going further, we're going to find these funny things called lollipop routes, which kind of look like an inverted lollipop, I guess. But this also calibrates incorrectly, and we want to make sure we calibrate these things correctly. So the way we've gone through this is we've gone ahead and assumed our network was almost perfect and gone ahead and automatically calibrated. What you might want to do also is plan for these calibrations ahead of time, and you can do that by managing the direction of digitization. So that's the little hidden info there, is calibration takes place increasing depending on the direction of digitization. If you want your calibration to work well, make sure your roads are digitized in the direction that you want the measures to increase. I think that's a fair comment to say. All right, So we only have a few minutes left. The next thing that we did want to do is go over events, but I don't think we got time to do that, actually. So well, I do apologize. I think both of us apologize about that. We took a little bit of time.
That's when the data's not ready for you. You know, it's tough. We had a lot of preliminary stuff to get through, but adding the events, it's not all that difficult. It's another type of a couple of tools. We'd run a dissolve, a locate features along routes, and then we would go ahead and create our event.
Yeah. So and the way you would see it being done is if you're looking at the box over here. If you right-click on this, there's a method to go new and actually add an LRS event. And again, this launches its own wizard to walk through. Of course, I'm editing. That's why I can't do it right now. But if I stop editing, if you right-click on this, go to new, you do have the ability to walk through a wizard to create these new events. And we can certainly help with that if anybody's interested after the fact. But one of the things I did want to show you is the actual schema, the best practices for data schema when it comes to these events. We have pre-cooked some of them, so I can't walk you through it. But if you look at the year added event, I'm just going to open it up. It's been symbolized based on the year that it was added. And if I open up the attribute table for this, you'll notice that there's quite a bit of detail in here. We do have our route ID, which identifies where that event is, the from and to measures, which end up becoming, as a result of what's called a locate features along route tool, which was part of the steps, which we've skipped, actually. But it does identify where those events take place, and this is all automatically done. The measures are calculated automatically. Here's our year added. There's our from date and to date to manage the temporality. It's created this thing called a GUID, which uniquely identifies it, and we can see that it has no error. The point that I want to make here is almost all of these attributes are supporting attributes. The only real data attribute here is that one data. In other words, events should be highly normalized, specific to the data you want to portray. In this case, we have a single column or a single attribute identifying the year added. If I look at classification, which I said was one of the other ones we wanted to do, I look at this, we're similar structure. There's our route ID, from measure to measure. On the right side, we have our GUID, we have our from date to date, and the location error. And we essentially only have two columns here identifying the road classification. That's it. We want to keep things as simple as possible. The other clue that we have less classification segmentation than there were segments, if you look at the number of records we have 1,600 records, whereas in our original road network you saw about 3,500. If you look at the year added, we have about 2,500 records in our thing. So what we've resulted with, and I apologize about rushing through this, is we've created a linearly referenced road network in road name, and we've added events, in this case classification, year added, oh, and of course, rail crossings, which were added as well. There they are up there, which provide the segmentation on our network. So in other words, we're allowing our data to segment our network, not the other way around, where we arbitrarily provide network segmentation. It's a complete flip of the way of looking at things, and the end result, it becomes more manageable into the future with larger groups of people. And not everyone needs to become an LRS or GIS genius to start interacting with this. And you'll find more about that on some of the webinars that Brandon had alluded to. So I think with 3 minutes left, we can probably go through a couple of the questions. If that's good, let's just do that quickly. So I'm just going to minimize. Let's see what kind of questions we have. We also have a link for the UC demo in San Diego. For those of you who weren't lucky enough to join us, you certainly can see the videos on demand from this link. And of course, we have some upcoming webinars and events. 3D Enable Your Data with ArcGIS Pro. I'm not going to read it because we're over a minute. You'll get this, this PowerPoint as we complete this. So thank you again for everyone attending today's session. This recording will be available online at resources.esri.ca/webinars. If you have any more questions, feel free to contact either myself or Brandon. Our email addresses are on the page right now. Thank you again.
Yes, absolutely. Thank you guys for joining us today. We hope you had as much fun as we did, and hopefully you learned a little bit of something about creating an LRS, and maybe you'll be a little brave enough to take it on yourself now.